I always thought that was kind of an odd way to state the directions to solve a right triangle. But when you're asked to solve a right triangle, what that means is that you're going to find all of the angle measures and all of the side lengths. So let's talk about these two things, talking about finding the angle and then the lengths of the sides. Okay. Well, what do we know so far about finding angle measures in a triangle? Well, I know that the sum is 180. And because we're dealing with right triangles, I know that the two acute angles are complementary, that they add to be 90. So I'm going to be using that information. And I know that also I can use some type of inverse trig function to find an angle measure. What do we know about finding sides of a right triangle? Well, Pythagorean theorem. And we know just a basic trig function will give me that as well, right? Sine, cosine, and tangent are all going to give me the ratio of like opposite over hypotenuse, you know, adjacent over hypotenuse, opposite over adjacent. So those are the four things that we're going to be using in order to solve a right triangle. Okay. In most all of these problems that we're going to be looking at with pictures already drawn out for you and giving you some just a generic picture, I think most all of these are going to be in degrees. So that's the first thing that you want to do here, is to be sure that your calculator is in degree mode. And this is really one of the most common mistakes that students make with working these problems, is that once we get past just the generic problems that don't really have context in like a word problem, which is just, you know, picture, then we're going to have some stuff in radians and some stuff in degrees. So again, the common mistake is that students will just forget to change to what mode they're supposed to be in. Okay, so here's my first picture. Right triangle, and I am told that this is 62.3 degrees, and I am told that this length C is 51. This is point A, up here is point B, and this right angle is point C. Okay, this is going to be little a, and this is little b. And notice that there's a certain way that these go. The side A is opposite angle A, side B is opposite angle B, side C is opposite angle C. Is that all that I'm giving here? Yep. Okay. So I need to figure out all these angles and all of the side lengths. And there's lots of different ways that we can go about doing this. I think that for me, the place that I tend to want to start is with the angles. If I'm given one angle, then I want to go ahead and finish up the angles, right? Because I already know two of them. This is 62, this is 90. So I know that these two are complementary. So if I just take 90 minus 62.3, that will give me this angle up here. So 27.7 degrees. So now I've got all of the angles, and I have one side length I can use a trig function to help me figure out one of those other side lengths. And you've got lots of options here, right? You could take this angle and get a trig function from it, or this angle up here. I tend to use the one that's down here on the bottom. And if I want to find this side A, I know that is opposite over hypotenuse for the sine of 62. Right? The sine of 62.3 degrees is opposite over hypotenuse, so A over 51. So this A value is 51 times the sine of 62.3 degrees. So you just stick that into the calculator. 51 sine 62.3. And you should get approximately 45.2. Y'all with me so far? Okay. So now I know this side. I've got a couple of different options to figure out the other side. I know two sides of a right triangle. I can use the Pythagorean theorem, or I could use cosine of 62. It doesn't matter, however you want to do to get that other angle. And I will tell you that depending on which method you do and how far you take out your decimal here, if you're using Pythagorean theorem, your rounding may be off slightly compared to what the book has or my math lab has, especially if it's a multiple choice thing. So on the test Monday, if you're off by just a little bit, I wouldn't worry too much about it. I think that if you're off a little bit, it's going to be obvious which one's the right answer. So like 50 or 45.2, maybe 45.3. It's not going to be way off. It's just going to be a little bit off. All right, so figuring out side B here, I'm going to look at cosine of 62.3 degrees. And the cosine is adjacent over hypotenuse. So B over 51. So B is going to be 51 times the cosine of 62.3 degrees. And you're going to stick that into the calculator and you get approximately 23.7. Any questions with this? Okay, let's look at a second type of problem here. Here I'm given, this side is 22, this side is 18. This is going to be C. This is little b, little a. This is big A, big C, big B. So I know two of the sides, and I don't know either one of these two acute angles. If I want to look at some type of trig relationship with this angle A, then what I'm looking at is the opposite and adjacent, or adjacent over opposite, so either tangent or cotangent. So I am going to actually use tangent here because that's the button on my calculator. It's easy to get to. The tangent of angle A is opposite over adjacent, 18 over 22. So that means that A is going to equal tan inverse of 18 over 22. So you have to be sure that you know how to put that into the calculator. The tan inverse is this second function key above your tan key. So second tan, 18 over 22. and I get approximately 39.3. So this angle is 39.3 degrees. So I can use the fact that these two angles are complementary angles to find this one. Just do 90 minus the 39.3, and that will give me 50.7. And then to find C, I can use a trig function, or I can use the Pythagorean theorem. And if you use the Pythagorean theorem, a squared plus b squared equals c squared. You have 18 squared plus 22 squared equals c squared. So that's going to give you approximately 28.4 for the length of the hypotenuse. Let me zoom out there so you can see that. Any questions with that so far? Okay. You're going to be given some problems that are a little bit more involved there. Draw this out, draw this. And here I'm told this angle is 32 degrees. This angle is 25 degrees. This length is 120. And I am asked to find this whole length here, which they're going to call x. Well, I have two right triangles. And if you're looking at this angle of 32 degrees, I know adjacent side. If you're looking at this angle of 25 degrees, I know an adjacent side of 120. What I want to do is to figure out this length, which I'm going to call A, and this length, which I'm going to call B, and I just add them together, I will get the whole length that they're calling X. Let me see here. If I'm just looking at that right triangle that's on the top part of my picture, I'm looking at opposite and adjacent sides. So for angle or side length A, I am using the relationship of tan 30 degrees equals opposite over adjacent. So A is going to be 120 times the tangent of 32 degrees. And I'm not going to stick that in my calculator right yet. I'm going to come down here and look at B. And for angle B, I've got 20, or side B is what I'm looking for. So angle B is 25 degrees. So the tangent of 25 degrees is B over 120, opposite over adjacent. Put that down there, right? That's 120. So side B is 120 times the tangent of 25 degrees. So if I take side length A, side length B, add them together, I will get this whole length of X. So I would wait until you get this set up and then put this all in the calculator all at once, because that way you're not worried about the rounding. So you put all of that into the calculator. And 120 times tan of 32 plus 120 tan of 25 degrees. And you add that together and you're going to get 130.9. This angle right in here is going to be 24 degrees. And this whole great big angle, I'm going to say is 37 degrees. And I want to find this distance here. Well, it's kind of like the problem that we just did, only it's a little bit backwards. Instead of finding each of the smaller sides and adding them together, what I want to do is to find this length here that I'm going to call A and this length here that I'm going to call B, and take A minus B to get the X value. And with this problem, sometimes I think that it helps to take these pictures and separate them out into two right triangles. So if I look at this big right triangle, I have this is 37 degrees. This is side length A. Oh, and I'm told that this down here is 85. Right, so I can use tan inverse to help me get, not tan inverse, but I can use tangent in order to get me A. And then if I look at this smaller triangle that has an acute angle down here of 24 degrees, then I can use the tangent there to get the value of B. So I know A, I know B, I can subtract that to get the value of X. Does everybody understand that this bigger angle here is 37, this whole big triangle is 37 degrees? Okay, so I've got opposite over adjacent, so I have tangent that I'm dealing with both of these. The tangent of 37 degrees, A over 85. So A will be 85 times the tangent of 37. Here I've got the tangent of 24 degrees is opposite over adjacent. So B would be 85 times the tangent of 24 degrees. Now going back to my original picture here, I know that X equals A minus B. Right? This part up here is this whole length minus this part. Right? X is A minus B. So I've got A is 85 times the tangent of 37 minus 85 times the tangent of 24. So you just stick that into the calculator to get your answer. Approximately 26.2. I'm going to skip over problem 5 here and go on to problem 6. Problem 5 is just like problem 4 on my handouts, except that the picture is just rotated to where that the side lengths that you're looking for are, instead of like this, instead of vertical, it's just like this if it's horizontal. Right? Same thing. This problem is a little bit different. Let's see, what am I told here? I'm told that this is my right triangle. This is 54 degrees, and this angle is 27 degrees. And I know that this length right in here is 440. And what I'm going to be asked to find is the height of this triangle here. X. I know that this right triangle here is going to have angles that add up to be 180, and these two acute angles are complementary. So that means this angle is 36 degrees. Now, if you ignore this line here in the middle and you look at just this great big right triangle, I know that This whole angle up in here is going to be complementary with angle 27. So you could do 90 minus 27. So this whole great big angle that my pen is covering up, 90 minus 27 is 63 degrees. Well, I know that this part of the angle is 36. So that means this angle in here is 27. Okay. So this is going back to quite a bit of high school geometry. Now look at this obtuse triangle that I have. If you have angles that are equal, then you know that those sides that are opposite those are going to be equal as well. My picture does not look like it, but this side is going to have the same length as this side. This side is 440, so that means this side is 440 as well. So now I know enough information that I can set up a trig ratio in order to figure out this length here. If you do cosine of 36, you have adjacent over hypotenuse, and that will give you, you're able to solve that for x. Or you could use the sine of 54 is opposite over hypotenuse.